right, so we're in Math 20.3. We're doing Unit 3 graphing. So here we have our key, okay, for our videos. This is our video. Woohoo! And I'm Mrs. Finley. So let's get going on some graphing. So the first thing we're going to look at is different types of graph. This first graph that we have, this is a line graph. And more specifically, it's a broken line graph, because the graph is not one straight line, okay? So we have changes and shifts in it. One thing you notice about this graph is that we have a title, we have the axes labeled on the graph, so that tells us what each axis is measuring. And all graphs should have a title so that we can understand what's going on. This next one is a bar graph. Again, if we look at it, we have a title. We don't have the axes labeled, but we can tell that these are months and that it says in the title these are scoops. Usually we would want to put some more information on each of those labels to kind of talk about what it is. We have another kind of bar graph here. Again, a title. We're comparing two products, and we have our information there about what we're measuring. So this is a bar graph, but this graph shows comparison. So it is comparing two products, okay? And then the last graph here, actually it's not our last graph, it's our second one. It's a circle graph. And circle graphs show percentages or fractions of the whole, okay? So it is a percentage, each section, or it's a fraction of the whole. So you're always looking with a circle graph at a whole picture and just how much we've broken it up into. Again, with this graph, you still have a title. And then in this case, it has a legend to kind of explain what each part is, okay? Last graph is, again, another kind of bar graph. Some interesting things to point out here is that on the x-axis, it doesn't start from 0 because it wanted to save space, but we still have our axes labeled. We have our title. It's very important that you have a title on all of your graphs. Okay, so notice that all of these graphs have a title, axis piece legends, and a legend when needed. Please include all of these when you're doing your graphing, and we'll walk through what needs to be on a graph to make sure we've got that covered. Okay, so let's move on. So definitions. An independent variable is on the x-axis, which is the horizontal axis, right? And this variable is not influenced by anything, okay? So that's why you saw things like months. They're not going to change. Days, that sort of thing would be on our x-axis. One was heights. The heights are not going to be influenced by anything. The dependent variable is on the y-axis, so it's up and down, and it changes depending on the independent. Okay, so as the months change, so does the amount of rainfall. We'll look at one of those later. The range is the difference between the highest and the lowest numbers in a set. And we have to figure out the range to help us figure out how we're going to label our axes. We want to make sure that we can fit it all on our graph, that we don't start graphing and run out of room. So we want to assess the range before we start graphing. Scale. Scale are the numbers we put on the x and y axes to show our data. Okay, So scale, we decide if we're going to go up by 5s or 10s or 2s or 4s, etc. Or if it's months, we go up month to month, or maybe we go up every 6 months, depending on what we're graphing. Discrete data, it's data that can only be whole numbers. So things like number of people, you wouldn't count half a person, or age, things like that. Months, those would be discrete data. Maybe I'll add months to that list because it's not a bad thing to do. So you have some example. And continuous data is data that can be fractions or decimals. So money, temperature, you can have half a degree, anything that you can do that can be a part, okay? To interpolate means we're estimating between points on a graph, and to extrapolate means we're going to estimate beyond the graph. So if we have a graph, I'll draw it over here. So if we have a graph and I have this point and this point and this point, interpolating would be the information between, but extrapolating would be here beyond. It's guessing what happens after. Okay, so that would be the difference. And we'll do a few examples where we kind of see how that works. So, drawing graphs. I said we talk about this. This is very important. And, you know, we want to make sure that we do all these things because these are easy ways to do well. First, put a title at the top. What are you graphing? Number of ice cream scoops per month of the year. How many do I sell? Put that title on the top. Okay? Determine your independent variables. So determine which one depends on the other. And the independent is going to go on your x-axis, and the dependent is going to go on your y-axis. Big hint, if you ever have time, months, years, days, minutes, it will always be your independent variable because time cannot change. It's a constant measure, okay? Determine your range so you know what to count by. Very important for how you sketch out your graph. Once you've determined that, then you can put number scales and titles on both axes. You want to include that so people know what the measurement is. And then once you've done all that, then you can draw your points and bars. Now, before we dive into reading graphs and such, I want to do a little percentage review because this comes up with circle graphs in particular. So it's very important to review percentage. We would have done this in previous grades, but we want to make sure we do it. So what is 45% of 24? Well, 45% we can write as a decimal by dividing by 100. And it would be 0.45. Then we just times it by 24. So 0.45 times 24 equals 10.8. Okay? So the way we get from a percentage to a decimal is we divide by 100, okay? Once you've converted it into a decimal, you can just multiply. Now, here it says if you spend 8 hours a day sleeping, what percentage of the day do you sleep? Well, 8 divided by 24 equals 0.3333, etc. We times that by 100%. And we get 33.3%, okay? So if we're going from our fraction to our thing, once we have it in our decimal form, we just multiply by 100, okay? So let's write that out. Decimal 2%, we times by 100%, okay? So let's look at this. This is how it's going to relate to circle graphs, which we aren't doing today. We're doing later in the week, but it's good to know now and do a little practice before you jump into it. Given that a circle has 360 degrees, how many degrees are in a 19.5% of a circle? So we take our 19.5%, we divide by 100, and we get 0.195. Then we take that 0.195 and we times it by the 360 degrees, and we're going to get 70.2 degrees. Now, if you're sketching that, you're probably going to just draw 70%, but that means if we have a circle and we have 19.5% of it, it's also equal to 70.2 degrees. That's what that is. Okay? Alrighty. Now, for today's practice, you're just practicing with the percentage, not the circle graphs themselves, but it's good to review that. Line graphs. Today we're going to focus a bit on line graphs, and then later in the day we're going to talk about plotting on the Cartesian plane, or the XY coordinates. So line graphs are usually used to express a trend. They are used to show how something changes over time. You can use line graphs to interpolate and extrapolate information. Solid lines are used to indicate continuous data, so we can interpolate. Okay, we can make guesses between the points. Broken lines are used to indicate non-continuous data, so we cannot interpolate, because those broken lines mean that, and it's also hard to extrapolate as well, but we can extrapolate a little bit on both solid and broken line graphs. Okay. So we can look at general trends. Okay. Remember, interpolation is estimates within data. Actually, I'm confusing this. It's non-continuous data, so we can't extrapolate. But between each points, we can interpolate. Oh, Mrs. Finley. Sorry, brain burp. Extrapolate. But we can't interpolate. We can't interpolate. Okay, interpolation is estimates within data, so it's between points. And extrapolation is estimates beyond data. So it's outside the data. Okay? We're going to use this line graph here. This is a nice continuous graph. We see a nice straight line. And we're going to just learn how to read it. So let's look at the pieces that it needs to have. It has a title. It has labeled axes. And these axes have numbers assigned to each of them. Now, first thing we're going to do is it says, what is the cost for 200 yearbooks? So we are going to use our ruler. Rulers are nice. We're going to go right back to the correct page, because that happens sometimes. I accidentally touched the side. So 200. So we'll connect it up to 200, and then we're going to see where that meets up on the side. And that meets up right at the 5,000. Okay? So what's the cost for 200 yearbooks? $5,000. Now, approximately, how much does 175 yearbooks cost? So let's try that one. Now, 175, we've got right here. And we go over. And now it's a little hard to read. it's not quite at the line there for 4,000, and it's not quite in the middle. So I'd say we have approximately, and that's your symbol for approximately. It's not really an equal sign. I'm going to say 4,250 maybe. Yeah, we'll guess that. It's not quite halfway in the middle, but it's not at the 4,000. So it's approximately. Then it says, use extrapolation to determine how many yearbooks could be purchased for $10,000. Now we have to use extrapolation because 10,000 is not on the graph. So we have to take our ruler and we've got to extend this line. So when we do that, we extend it up, right? And then we're going to match it up with 10,000. So matching it up with 10,000, I want it a little lower. Right there, and then let's see where it meets on this line. Okay, and I can only get so precise with my ruler. So it's approximately at 400 for that. Okay, it's pretty close. Describe the trend in this graph. So what's happening overall? The trend is like our slope. Remember our slope unit? So what we're seeing as yearbooks, sales increase. So does the gross income. Okay, so as we sell more books, we make more money. That's basically that. How much does each textbook cost? Justify your answer. Well, if we take our $5,000 that we made for selling 200, we would get $25. Now, is that in line with our other numbers? Well, let's just double check. We also approximately said 4,250 for 175 yearbooks. So 4,250 divided by, and that's about 24.3. So it's in the ballpark. This was an approximation, right? So if we look at that, we're pretty close. We could also take our 10,000 and divide it by our 400, and that works out to 25 per book. So, I think if we had a better graph in terms of quality of the lines, we might be able to make a better assessment. Okay, but I just took one of the points, and since it's a straight line, it should be pretty accurate. Now, let's look at this next one. Seriously, we're going to look at these crickets. So we're analyzing this. Now, there's a couple things I want to correct with this graph before we continue. First, it's missing a title. So this would be, we're talking about crickets and temperature. Crickets notice temperature. At least their chirps change with the temperature. And some people say that the number of chirps, a cricket chirps in 1 minute can actually be used to find out the temperature. So they took a few readings and they graphed it. So across the side, we do have a nice labeled graph across the side. So we have a title there. Sorry about that. I want this. I want to just highlight it. And this is the number of chirps per minute, but we're missing a title on the graph. So this is cricket chirps per temperature, and that's in degrees Fahrenheit. It's an American graph. So this on the bottom is temperature in degrees Fahrenheit. So we needed to have a title on our graph, and we needed a title on our x-axis. Okay, temperature would be our independent variable, and our number of chirps would be our dependent variable. Okay, so we're going to use this graph to help us answer these questions. Suppose a cricket chirps 80 times in 1 minute. What is the temperature? So let's take a look. At 80, so 50, 60, 70, 80, we're looking at here. So we've got to extend our line. So let's take our ruler and let's extend our line so we can match it up. Okay, extending our line up. And when we take our ruler over, am I reading? Yeah. Oh, wait. Sorry, I'm reading the wrong information. Oops. It's not 80 degrees, it's 80 times. So we're going to extrapolate later. So 80 chirps is here. So let's draw a line there. And then that matches up like so below. So it's around 60 degrees Fahrenheit. My apologies. This is what happens when you don't read your question carefully. Then the next question says, suppose the temperature is 70 degrees Fahrenheit. How many times a minute would you expect a cricket to chirp? So here we're going to go up to 70. And we draw in our line. And then we draw in our other line. And we're going to see that we are at, each of these goes up by 10. So 100, 110, 120. 120 chirps per minute. Okay? At what temperature do you think crickets stop chirping? Well, down here at the bottom, we have 0 numbers of chirps. Now that is not quite 40. So I would say that's approximately, if I'm looking at that, it's approximately 38 degrees Fahrenheit. You might say 37, you might say 39. So we'll say approximately, okay? Now it says, suppose a cricket chirps 70 times in 1 minute. What is the temperature? So let's look back at our graph with our ruler. So 70, that's going to be right here. I knew I'd have to do it at one point. Is it 70? Oh, wait, doing it the wrong way again. 70 chirps per minute. So right here. So we draw our line down. So again, it's not completely all the way over. So we would say that that would be, approximately, I would say about, it's going to be about 57 degrees Fahrenheit. Okay. It says, suppose a cricket chirps 125 times in 1 minute. Would you expect the temperature to be warmer or colder than 70 degrees Fahrenheit? Well, at 70 degrees Fahrenheit, it chirped 120. So if it's chirping more, I would expect it to be higher. I can use my graph if I need something more precise. Then it says, suppose the temperature is about 87 degrees Fahrenheit. About how many times a minute would you expect a cricket to chirp? So looking at our graph, we are going to look at 87 degrees Fahrenheit. So here is 80, 87's around here. So we draw our line up, and what we can see is that it goes off the graph. We don't know exactly how much. We could guesstimate, we could extrapolate further, and I think it's definitely going to be more than maybe it's going to be 165 chirps per minute. Okay, that's a guesstimation because our graph cuts off. There's other ways to find it, but based on that graph, we don't have the information. As the temperature gets warmer, what happens to the cricket chirps? That they increase. Okay, we get more chirps per minute, okay, as it gets hotter. Alrighty, so that's just reading that graph. Now, this is I believe our last example. So this is gonna give us a little practice in actually drawing a graph. So Mike Sobel from Global News records, observes, and transmits weather information such as temperature and precipitation levels. He recorded the amount of rain in Banff in the table below. So we've got this table here. And we've got the amount of rain in Banff, the month, and the amount of rain in millimeters. Okay, so we're going to make this graph. So first thing we're going to do is we're going to put a title, which is amount of rain in Banff per month. And I'm just going to put millimeters here. I know I'm going to put it on the sidebar as well. Now looking at our month is going to be our independent variable and our amount of rain is our dependent. Remember, it's a measure of time. So if you have a measure of time, it's always going to be your independent variable. So it will be on the x-axis. So let's take a look on our graph. So this will be months. And this on the side will be the amount of rain in millimeters. Okay. Now for months, it's pretty straightforward. I can do January, February, March, April, May, June, July, August, September, October, November, December. For the millimeters, though, for the rain, we want to figure out what is our range. Well, my lowest rain is 22 and my highest is 82. So my range is 82 minus 22, which is 60. Now on the side I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can cover up to 80. I can just start it at 0 and go up by 10. 10, 20, 30, 40, 50, 60, 70, 80, 90. Every once in a while I do that, I write something wrong. Okay, now we're going to plot our lines. For January, we had 28. For February, we had 22. For March, we had 23, so that'll be in between those two. For April, I had 32. For May, I had 60. For June, June was the big month, 82. July, I had 54. What a big drop. August, I went back up to 60. September, 42. October, 29th. And November, 27th. So, between two. Oh, I'm too low on that one. And I'm too low on that one. Sorry. October's 29 and November's 27th. Now, we're going to connect those points. It's a broken line graph. We can't draw a nice straight line because it changes so rapidly between each month depending on weather patterns, which makes sense. Looks like the Banff Mountains, doesn't it? Now, we don't know December. It's a question mark. I have a feeling that's going to be one of the questions we're going to answer. Okay. So looking at our questions, we have a couple of questions. It says, based on the information shown above, what month would be best for camping or hiking? Explain your choices. Well, looking at this graph, if we're going to go camping or hiking, we probably want to go in the warm months. So somewhere between May and August and September, right? Like September, we're back in school. It starts to get cold. So somewhere in there. So what I would do is I would pick the one with the lowest amount of rain in those warmest months. So my choice would be July because it's the warmer months with the least rain. Okay? Of course, if you had a different reason, you could justify your choice with a different reason. If you said, you know what? I actually like it when it's a little cooler, so I'm going in September. That's totally fine. You can make that decision for yourself. Okay? Or if you said, nah, April's fine. I'll go in April. There's very little rain. I don't mind. I can bring a heavier sleeping bag. Again, it's up to you. Now, use the graph to predict what the average amount of rain might have been in December. What assumptions did you make? Well, looking at December's a cold month, right? It rained, if we look from September, October to November, the amount of rain is decreasing. does go up a little bit in January, but we generally follow the trend of the months immediately before us. So I'm going to guess that it goes down to 24. You could have a slightly different range, but I'm going to say it's about 24 millimeters because the rain is decreasing. And it's a cold month, right? We're moving into December. There's usually a lot of snow and less rain. Okay, so that is our first lesson for today. And then you're going to do some practice, and then later we're going to look specifically at coordinate graphs.